Assalamualaikum and good day everyone. In this video, I want you to get some experience working with counting sample problems involving permutation as well as combination. So, we're going to go through this together. As we go through them, I want to talk about some of the different formulas as well as some of the different definitions. We're going to be working with permutations, combinations, factorials, probability, and a few of the problems as well as the fundamental counting principles. So let's dive into the first theorem, and we'll kind of explain this as we go through it. For the first one, it says if an operation can be performed in n1 ways, and if for each of these ways a second operation can be performed in n2 ways, then the two operations can be performed together in n1 multiplied by n2 ways. The first example, how many sample points are there in the sample space when a pair of dice is thrown once? What do you think of this problem? Well, there's a couple of different ways to do this problem. One way to do it is to use the fundamental counting principle. What would you do if you would diagram this out like what we did previously? So, there's 6 ways. The first die can land in anyone, and then how many ways are there for the second die? Six also. Therefore, n1 times n2, there are 36 possible ways. And this is the fundamental counting principle. And you just see how many choices in each category and you multiply them together. So we'll see another example here. A developer of a new subdivision offers prospective home buyers a choice of Tudor, rustic, colonial and traditional exterior styling in ranch, 2-story and a split level floor plans. In how many different ways can a buyer order one of these homes? So the fundamental counting principle here can be verified by constructing tree diagrams and counting the various paths along the branches. Here, n1 equals to 4 branches corresponding to different exterior styles, and there will be n2 equals to 3 branches extending from each of these 4 branches represent different floor plans. So this tree diagram yields to n1 times n2 equals to 12 choices of homes given by the path along the branches. Next, we consider the second probability theorem, where if an operation can be performed in n1 ways, and if for each of these a second operation can be performed in n2 ways, and for each of the first two a third operation can be in n3 ways, and so forth, then the sequence of k operation can be performed in n1 times n2 and so forth until nk ways. Let's take a look at example 2.14. Sam is going to assemble a motorcycle by himself. He has the choice of ordering motorcycle from 2 brands, a motorcycle body frame from 4, side mirror from 3, and a pedal brake from 5 local stores. How many different ways can Sam order the parts? Okay, let's see. Since n1 equals to 2 and 2 equals to 4, n3 equals to 3, and n4 equals to 5. Then, the multiplication of all four number of ways will give us 120 different ways to order the parts. Next, how many even 4-digit numbers can be formed from the digits 0, 1, 2, 5, 6 and 9 if each digit can be used only once? Since the number must be even, we only have n1 equals to 3 choices of the units. 3 choices of the unit which is 0, 2 and 6. However, for a 4-digit number, the thousand position cannot be 0. Hence, we consider the unit position by two parts, 0 or not 0. If the unit position is 0, n1 is equals to 1. And then we have n2 equals to 5 for the thousand position, n3 equals to 4 for the 100 position, and n4 equals to 3 for the tens position. Therefore, in this case, we have a total of 60 even 4-digit numbers. So, here you can see 1 possible ways for the unit position, 3 possible ways for the 10 position, 4 possible ways for the 100 position, and 5 possible ways for the 1000 position. So that's make it 60. And then, on the other hand, if the unit position is not 0, n1 would be equals to 2. There are 2 because we have 0, 2 and 6. So if it's not 0, it is probably 2 or 6. So n1 equals to 2. So we have n2 equals to 4 for the 1000 position, and then n3 equals to 4 for the 100 position, and n4 equals to 3 for the 10 position. In this situation, there are a total of 96 even 4-digit numbers. So you can see the arrangement here from the unit, tens, thousand, 100 and 1000 position. Next, what is permutation? It is a mathematical technique that determines the number of possible arrangements in a set when the order of the arrangement matters. The formula is P equals to n factorial. In this example, we consider the 3 letters A, B and C, and what are the possible permutation for these 3 letters. So, the formula is P equals to n factorial. In this case, n equals to 3. So, 3 factorial equals to 3 times 2 times 1, which is equals to 6 possible arrangement. By definition, 1 factorial equals to 0 factorial, which is also equals to 1. Next example, we have a password consists of 3 letters F, U and N followed by 5 digits 1, 2, 3, 4 and 5. So, how many ways can you arrange possible passwords? There are 3 factorial ways for the alphabet and 5 factorial ways of arranging the digits 1 to 5. And then multiplying 3 factorials with 5 factorials, you'll get 720 ways. Here is theorem 2.1. The number of permutation of an object is n factorial. To consider this example of 4 letters arrangement A, B, C and D, what is the number of permutation that are possible by taking 2 letters at a time out of 4? So how many choices are there for the first letters? So imagine if you're picking these letters out of a bag, well, there would be 4 choices, right? And then once you pick one of those letters, there's going to be 3 left. So you're going to have 3 possibilities for that. And if you multiply those together, you're going to get 12 different so-called words involving the 2 letters. Notice in permutation, the orders matters. Where in this case we have, for example, AC and CA. In general, n distinct objects taken R at a time can be arranged in n times n minus 1 times n minus 2 and so forth. As for theorem 2.2, the number of permutation of n distinct objects taken R at a time is NPR equals to n factorial over n minus r factorial. Here is the example. How many different ways are there to select a monitor and an assistant monitor from a group of 10 students? In this case, we identify n equals to 10 and then R would be equals to 2 because you have to select a monitor and also an assistant. So to calculate the possible ways using a formula of n and r, so NPR is 10p2 equals to 10 factorial over 10 minus 2 factorial, and this would be equals to 10 factorial divided by 8 factorial equals to 90 ways. Another example, there are 3 awards will be given for a group of 25 truck drivers in Shell company in 1 year. Okay, so if each truck driver can receive at most 1 award, how many possible selection are there? Okay, so using the same formula, NPR, so in this case, we can say n equals to 25 and then r will be equals to 3. So 25p3 equals to 25 factorial over 25 minus 3 be equal to 25 factorial over 22 factorial. And the answer would be 13,800 ways. What could be interesting is to see if each truck driver can receive any number of awards. How many possible selections are there? Okay, let's try example 2.21. This is quite a long one and interesting. In the case of a bus driver and an assistant bus driver to be chosen from 50 drivers. And there are 4 conditions here. The first one, there are no restriction on the possibilities. The second one, A will serve only if he is selected as the driver. The third one, B and C will serve together or not at all. And then the fourth one, D and E will not serve together. So let's try the first one, without restriction. So if there are no restriction at all, then we have R equals to 2 and N equals to 50. So we have 2, 4, 5, 0 possibilities. Okay, for part B, where A will only serve if he is a driver. So in this case, we divided into 2 parts, where the first one is the part that A is selected, and the second one, A is not selected. Okay, so kalau A dipilih as a driver, then tinggal 49 drivers only can be selected as an assistant. So in this case, we identify N equals to 49 and R equals to 1. Okay, and we get 49 ways. For the second part, if A is not selected as driver, so because A will only serve if he is a driver, he will not go for an assistant. Therefore, kalau dia tak diselect as a driver, so the remaining 49 drivers still as N, because kita kena minus A because it's not selected. So daripada 49 ni, R akan jadi 2. Okay, so the permutation would be 49P2, and there will be 2, 3, 5, 2 ways. Okay, then we will get the total number of choices, 49 plus 2352 equals to 2401. Next, in the case of B and C, will serve together or not at all. Okay, yang ini pun kita bahagikan kepada 2, case 1 and case 2. So case 1, B and C selected, and case 2, B and C are not selected. So selected. Okay, kita buat yang first one dulu. So kalau B and C are selected, B would be the driver and then C as the assistant ataupun sebaliknya. Okay, in this case, kita ada N equals to 2, R equals to 2. Then there are 2 possibilities. Okay, so for the second case, where B and C are not selected, So maksudnya dia nak serve together ataupun not at all. Okay. So in this case, we identify R. So kita kena minus B and C ni because it's not selected and they will not be working together. So 50 minus 2 dapat N equals to 48. Okay. Then 48 R, still kita ada R equals to 2 because we want to select driver dengan assistant. So 48 factorial divided by 46 factorial, we will get 2256. So in total, we have 2 plus 2256 equals to 2258. Alright. Next, the yang keempat, D and E will not serve together. So kat sini kita divide into 5 cases. So the first 1A is if D is selected as a driver, and then 1B, D is selected as an assistant driver, and then E is selected as a driver, and then E is selected as an assistant driver, and the last part is both D and E are not selected. Okay. So kita tengok macam mana kita nak buat case 1A dulu. Okay, kalau D is selected as a driver. Okay. Okay, so kalau D is selected as a driver, maksudnya E, kita kena tolak E juga. So kita tolak D dan kita tolak E. So in this case, we have N equals to 48. So 48 sebab D dah confirm jadi driver, so kita tinggal cari assistant driver. Therefore R equals to 1. Okay, then kita dapat 48 ways. Okay, 48 kebarangkalian lah. Okay, and then untuk 1B, if D is assistant driver, sama juga. Kalau D assistant driver, kita kena tolak juga dengan E. So N would be equals to 48. 48, then R equals to 1 sebab kita kena cari driver, sebab kita dah ada assistant driver. So we will also get 48. Okay, untuk case 2A, if E is selected as a driver. So sebenarnya case 1A dengan 2A sama. Sebab kalau E is selected as a driver, kita kena minus juga dengan D because they are not going to work together. So N would be equals to 48 and then R equals to 1. Okay, so kita dapat 48 lagi. Sama juga case 1B. Okay, 48 juga. And then case 3, both D and E are not selected. So kalau D and E are not selected, kita dah kena tolak 2, N tolak 2, dapat 48. And then R kita equals to 2. Okay, so kita akan dapat 2256. Sebab 2 ni R, kita kena cari driver and assistant driver. And then finally kita dapat total dia 48 times 4 plus 2256, and the answer is 2448. Alright. Okay, next theorem is theorem 2.4. The number of distinct permutation of n things of which n1 are of one kind, and 2 of a second kind, and so forth, and k of a k kind is equals to n factorial divided by n1 factorial times n2 factorial and so forth. Okay, so ini adalah formula untuk theorem 2.4. So let's see if we have some example to better comprehend the theorem. Okay, so here we have a college football training session. The defensive coordinator needs to have 10 players standing in a row. So among these 10 players, there are 1 freshman, 2 sophomores, 4 juniors, and 3 seniors. So the highlight this. Okay, 10 players. So how many different ways can they be arranged in a row if only their class level will be distinguished? Okay. Okay, so according to the formula, kita ambil n factorial here. So n is 10, and then n1 equals to 1. This is n1, and then n2, n3, and 4. Okay, so it is equals to 12,600. Okay. Okay, next theorem we have the number of ways of portioning a set of n objects into R cell with n1 elements in the first cell, n2 elements in the second, and so forth. Okay, so let's see some example. So in this example, we have to find how many ways can 7 motor cars be assigned to 1 triple and 2 double parking lots. Okay, so we have 7 motor cars, and then 1 triple and 2 double parking lots. Okay, alright, so in this case we have n equals to 7 here, and then we have n1 equals to 3, and then n2 equals to 2, and then we have 2. So n3 equals to 2. Therefore, will be 7 factorial divided by 3 factorial times 2 factorial times 2 factorial. We get 210. Next, okay, combination. What is combination? In many problems, we are interested in the number of ways of selecting our objects from n without regard order. These selections are called combination. It doesn't take into account the orders. Okay, let's see. The number of combination of n distinct objects taken R at the time is NCR, which is equals to n factorial over, so NCR equals to n factorial over n minus R factorial times R factorial. So let's see some example. A boy asks his mother to get 5 Game Boy cartridge from his collection of 10 arcade and 5 sports games. How many ways are there that his mother will get 3 arcade and 2 sports game respectively? So here we are going to solve using combination. So the first one, the number of ways selecting 3 cartridge out of 10. The second one is to select, this is the first one, 3 cartridge out of 10. The second one is 2 cartridge out of 5. Kita gunakan combination 10C3. 10C3 dapat 10 factorial minus 10 minus 3 factorial times 3 factorial. Kita akan dapat 120. Okay, next one 5C2. So maksudnya N adalah 5, R adalah 2. So sama juga kita apply the same formula, 5 factorial over 5 minus 2 factorial times 2 factorial. Then we get 10 ways. Therefore, the total is to multiply 120 with 10. So in the end, you'll get 1,200 ways. The final example of the day is to find how many different letter arrangements can be made from the letters in the word of statistic. Using the same argument in the discussion for Theorem 2.6, in this example, we can also actually apply Theorem 2.5. So, to solve this, here the word statistics have 10 total letters, with 2 letters S and T appearing 3 times each. And then the letter I appearing 2 times each. So we have 3 factorial for S, 3 factorial for T, 2 factorial for I, and then 1 factorial for A and C. Then 10 divided by the number of factorials equals to 50,400 arrangement. Here are some of the exercises with the answers for you to practice. Question 2, question 3, question 4, and until next video, thank you for watching.